Good morning, folks. I hope we all enjoyed the session about troubleshooting the auto sampler yesterday. Today's focus will be on sample preparation. We're actually going to focus on one of the most simple preparation techniques known as enzyme hydrolysis, in which we will use this previously made solution of enzyme, internal standards, and also buffer. So what we will do, we're gonna use this repeater, and aliquot. The repeater, of course, is set to 200 microliter, and it will dispense 200 microliter of the buffer solution, enzyme buffer solution, into each one of those microcentrifuge tubes. Prior to dispensing the Cal curve control as well as the patient sample into the appropriate microcentrifuge tube. Once that's done, each one of them will be actually incubated for about an hour and a half to allow the enzyme to do its job, which is to detach the sugar from the drugs that is in the patient samples. It's not too much. It may look a bit complicated, but it's really not a lot. As soon as you understand the process, it should be fairly easy to proceed and get that done yourself as a technologist. Well, I'm not expecting a personnel that has no clue about toxicology or sample preparation to understand this right away. But if you want further information on how to do this, you can simply visit us at scienticsanalytical.com, and we'll be able to show you in detail how to not only do this, but to also make the solutions that I'm currently using and prepare your own Cal curve control that we prepare weekly. Now, I hope I have enough of the buffer enzyme mix for those 50 samples that I have to prepare today. Otherwise, I'm gonna have to make more internal standard stack solution, because I believe I ran out of them yesterday. Hopefully that won't be the case. Now that I am done adding the internal standard, I'm gonna dispense the Cal curve control that we spoke about, which is those microcentrifuge tubes. If you see, it's a Cal 1 through Cal 7, and we have QC 1 through QC 3. The purpose of this curve and control is to accurately and precisely quantify the drugs detected by the mass spec that I'm pointing at right now. Of course, Cal 1 goes on to Cal 1, right? The pipette needs to be set at the proper volume level. In our case, it's 200. Again, you do not just choose to add 200. The amount you add will depend on a whole lot of factors, which we describe further in our website, and we actually plan on implementing a course in there that will show you definitely how to make your cal curve and controls and your stack solutions. If you notice, I use a clean pipette tip for every sample I'm dispensing. A lot of the labs use automatic liquid handlers that cost an arm and a leg. Well, we are not that big of a lab, so we are doing this manually. So we have to be very careful not to allow for contaminations. It's good practice to always check the label on your tube. Very good practice. It doesn't matter if you are the one who label it. Before you dispense Cal Curve or Cal 6, you need to see that's what it is, and you need to see that it's being dispensed in the corresponding microcentrifuge tubes. Otherwise, your curve will look really, really weird. Now we're done adding the calibrators and controls made in-house. We're going to dispense the external control purchased from one of those certified suppliers to further ensure that the result we're giving you guys, result provided to the providers, are accurate and precise. After all, we're dealing with people's life. We're dealing with folks that might be having trouble with the opiate crisis out there. It's in our best interest to make sure the job is done properly, and it's in their best interest. It helps all of us to make sure that every patient out there is cared for appropriately. So more controls we have involved in this system, the better it is for the lab, the better it is for the patients, and the better it is for the providers who rely on the technologists at the lab for accurate results. Now that we're done dispensing the Cal and curve and controls, we're going to add the patient samples just as we did for the Cal and curve, since they all have to be treated the same way. We can't go ahead and do one part and leave the other part for 2-3 hours later. It would not be done in the same conditions. The extraction response would appear. The difference between responses would appear when a bit obvious when you're going through your data analysis. Now make sure you dispense the right sample into the right microcentrifuge tube and dispose of the pipette tip in the waste beaker, so you do not risk using it for another sample. The better, the cleaner your sample prep, the easier the job. Once I'm done with the samples, I will vortex them. The vortex is another term used to vigorously mix everything, the contents inside the microcentrifuge tubes. It will be done like this, guys. Take a quick look. This is where we shake it. That's the vortex we're gonna be using to vortex all of those prior to incubating them for about an hour and a half.